60 seconds of pure Raptor power. SpaceX just shattered records at Starbase with the longest Starship static fire we've ever witnessed. But that's not all. The dramatic finale left everyone wondering, is Ship 34 still flight ready? Meanwhile, Booster 15 has already completed its testing campaign and rolled back to the production site, setting the stage for what could be a March Flight 8 launch. The question on everyone's mind, will this historic flight happen this month? Beyond the launch pad drama, we're tracking major developments across the space industry. Stoke Space is pushing boundaries, Vast Space just achieved a breakthrough milestone ahead of schedule, and NASA is preparing to send an autonomous robot swarm to explore the lunar surface. Welcome to Elon Musk 24 Hours. Let's dive right in. Starship updates, the race to Flight 8, Booster 15, quick and decisive testing. Booster 15 has completed what might be SpaceX's most efficient test campaign yet. After just one successful static fire, it was swiftly rolled back to the production site. This represents a major shift in SpaceX's approach. No multiple firings, no gradual ramp-ups, just one clean, decisive test. During the burn, all Raptor engines performed flawlessly, with telemetry showing optimal combustion parameters. The rollback gave us a good look at the booster's condition, revealing no visible damage or anomalies. This pristine state suggests SpaceX has solved previous issues that cause wear during static fires. With Booster 15 now at the production site, teams are likely performing minor refurbishments before it returns to the launch pad for stacking with Ship 34. Given SpaceX's urgency to maintain momentum, Flight 8 could be closer than many expect. Nostristers Ship 34, epic 60-second static fire with a dramatic finale. Now to the main event, Ship 34's record-breaking static fire test. What started as a routine full-duration burn evolved into the longest Starship static fire in program history, with Raptors roaring for a full 60 seconds. Throughout most of the test, Ship 34 performed perfectly. The engines maintained steady blue-orange plumes, indicating stable combustion. Engineers programmed multiple thrust profiles with visible engine gimbaling, simulating different flight phases. But in the final moments, something unexpected happened. Multiple loud booms echoed across Starbase, accompanied by brightness fluctuations in the flame. The engines shut down abruptly rather than following the expected sequence. Let's analyze what actually occurred. These weren't catastrophic events. No visible damage appeared on Ship 34. The flame trench remained intact with no structural failures. What we likely witnessed was a pressure fluctuation in the propellant system, or possibly a programmed abort triggered by sensors detecting parameters outside acceptable ranges. SpaceX now faces a critical decision. 1. Assess and potentially repair Ship 34, replacing any affected Raptors. 2. Switch to Ship 35, requiring its own testing sequence. History suggests SpaceX won't let this setback derail their momentum. Remember SN8's static fire mishap? They swapped an engine within days. Or Booster 7's dramatic overpressure event? They had it flight ready within weeks. The Starship program consistently demonstrates that testing to failure isn't a bug, it's a feature. Each anomaly provides crucial data for design improvements. As Elon often says, if things aren't failing, you aren't innovating enough. The end of Ship 32, when progress outpaces prototypes. Meanwhile, Ship 32 is being dismantled without ever reaching the launch pad. This fully flight-worthy prototype represented the final Block 1 Starship architecture, featuring improved thermal protection tiles and structural reinforcements. Why scrap such an advanced vessel? By the time Ship 32 was complete, the design had already evolved significantly. Engineers had identified optimizations that could only be implemented in new builds, making Block 2 vessels like Ship 33 and 34 substantially superior. Ship 32 served as a validation platform for numerous systems, manufacturing sequence improvements, tile application techniques, tank structural integrity tests, software integration validation. Interestingly, while Ship 32 was quickly cut into segments, those parts now sit by the high bay rather than than being removed. Could this historic vessel be preserved for display? It would make a worthy addition to aerospace museums as the final Block 1 design. Meanwhile, the iconic mural on the parking garage is being replaced with plain panels. Will we see a new design showcasing Block 2 Starship? Or perhaps artwork hinting at future Mars mission concepts? Narashur, Pad B progress, building the Future Launch Complex. Significant progress continues at Pad B with two major milestones this week. First, the reeving of the drawworks is complete. The intricate cable system woven through the chopsticks that will eventually catch falling boosters. Second, the critical actuators are now installed on the chopsticks themselves. These actuators are the precision components that will allow the arms to move with millimeter accuracy, enabling lifting, stacking, and eventually catching operations. Unlike Pad A's first-generation systems, these incorporate refinements from operational experience. With these components in place, Pad B is rapidly approaching functional status. The next phases include powering up systems, initial movement tests, and preparing for integrated stacking operations. The supporting infrastructure shows equally impressive progress. New tank farm components are being installed, with piping extending to the tower and around the flame trench. Preparations for a quick disconnect system are visible on the far side, with various pipe types already in position. One segment of the utility trench is receiving its covering, signaling readiness for water tank installation. Their foundations were poured earlier, with mounting blocks secured for efficient placement. Further down the line, what was recently just excavation is now becoming a culvert, with floor concrete poured and wall formwork erected. The rapid transformation demonstrates SpaceX's accelerated construction methods. What we're witnessing isn't just a copy of Pad A, it's a comprehensive upgrade incorporating lessons learned from operations. This truly represents Stage 0 Block 2, built on experience gained from the first launch facility. Mysterious testing at Test Tank 16.1. Away from the main site, intriguing work continues with Test Tank 16.1 at Massey. This experimental hardware features unusual components, nicknamed toothpicks by observers, whose positioning has changed after initial testing. Rather than using the massive Can Crusher 2.0, SpaceX employed a simpler approach. The tank remained beside the test cage, with hydraulic actuators applying precise pressure to the toothpicks. This elegant solution demonstrates SpaceX's pragmatism. Why build complex test equipment when simpler methods provide the necessary data? The purpose appears connected to a critical challenge with booster recovery. Previous catch attempts revealed stability issues. Massive boosters tend to wobble when held by Mechazilla. This oscillation creates risks for both the booster and potentially any Starship approaching the same area. The toothpick configuration suggests testing refinements to the catch points. By optimizing the mechanical interface, engineers can potentially create a more stable connection, eliminating dangerous movement after capture and supporting true rapid reusability. Ship 37, production acceleration. Production continues at remarkable pace. Our photographers recently captured Ship 37's nose cone through the Star Factory's upper windows, with tiling already underway. This area has become a reliable location for spotting new components, showing how quickly SpaceX has optimized workflow. The contrast between current production rates and those from just months ago highlights SpaceX's manufacturing evolution. What once took weeks now happens in days, with efficiency continuously improving. Doverwasser, vast space, commercial station. Ahead of schedule beyond SpaceX, Vast Space has achieved a significant milestone with its Haven 1 space station, successfully completing primary structure qualification testing on January 31, 2025. Ahead of schedule. The test adhered to NASA Standard 5001 guidelines, the same stringent requirements used for the ISS. The sequence included a decay leak check at 0.2 bar, passed without issues, a proof test at 1.8 bar with no leaks or deformation over 5 hours, an extended leak test maintaining 0.2 bar for 48 hours, exceeding NASA requirements, Following these successes, VAST has updated its timeline, now targeting system integration completion by year-end and launch in May 2026 aboard a Falcon 9 rocket. Haven 1 will accommodate 4 people in its cylindrical module, 10 meters length, 4.4 meters diameter, 45 cubic meters habitable volume. Positioned 500 kilometers above Earth, it features 1.1 meter windows, offering expansive planetary views, addressing a limitation of most spacecraft that sacrifice views for structural integrity. This accelerated progress brings VAST's vision of a commercial space station closer to reality than industry observers anticipated. NASA's Lunar Robot Swarm. Cadre mission. NASA is revolutionizing lunar exploration with its cooperative, autonomous, distributed robotic exploration, Cadre project. 3 suitcase-sized rovers will soon roam the moon's surface without direct human control. Unlike traditional models using single large rovers requiring constant supervision, these mini rovers will function as a coordinated team, mapping terrain, analyzing surface features, and navigating challenges cooperatively. This autonomy is crucial for expanding our exploratory reach. With communication delays making real-time control impossible in deep space, self-governing robot teams can maintain operations independently, continuing work during communication blackouts. Each rover carries imaging systems and environmental sensors for collecting lunar data. Their distributed nature allows covering more ground and approaching research from multiple perspectives simultaneously. The mission will launch aboard Intuitive Machines' IM-3 lander in early 2026 as part of NASA's Commercial Lunar Payload Services program, targeting an area of high scientific interest. This represents the first operational test of multi-rover autonomy beyond Earth. Success would validate a new exploration paradigm, potentially transforming planetary science. Future missions could deploy specialized swarms, some focused on sampling, others on mapping or infrastructure development, debris firm, experimental testing, and environmental responsibility. Recent Raptor tests at Massey's demonstrate SpaceX's focus on performance optimization. The 60-second duration matches orbital insertion requirements, allowing engineers to analyze the entire operational envelope. Flame coloration changes suggest experiments with mixture ratio adjustments, fine-tuning specific performance characteristics for different mission profiles. These refinements support both immediate orbital goals and future Raptor iterations. Meanwhile, SpaceX has intensified environmental monitoring around Starbase. Independent consultants conduct regular aerial surveys of protected habitats, while water quality stations monitor the sensitive coastal ecosystem. Wildlife observation protocols document animal behavior before, during, and after operations, with preliminary data suggesting local species have adapted to the facility's patterns. These measures represent SpaceX's commitment to responsible development, balancing rapid progress with ecological stewardship. All recent tests have remained within permitted parameters for environmental impact. As testing continues and Flight 8 approaches, the momentum at Starbase continues accelerating. SpaceX's iterative approach, building, testing, learning, and improving, drives not just Starship development, but the entire commercial space industry forward at unprecedented speed. As we've seen today, SpaceX continues pushing boundaries at an unprecedented pace. From record-breaking static fires to revolutionary testing methods, each development brings us closer to a truly reusable interplanetary transportation system. Flight 8 stands on the horizon as potentially the most significant milestone yet in the Starship program. What makes this moment in aerospace history so extraordinary isn't just the technical achievements. It's the relentless momentum driving humanity toward becoming a multiplanetary species. Every test, every new component, every refined process accelerates us toward that future. If you found value in today's update, hit that like button to help more space enthusiasts discover this content. Our channel metrics show over 4 million returning viewers who haven't subscribed yet. Take a second to check if you're one of them. Subscribing costs nothing, but helps us deliver these updates directly to you. Thank you for watching Elon Musk 24 Hours. See you in the next episode as we continue tracking humanity's journey to the stars. 60 seconds of pure Raptor power. SpaceX just shattered records at Starbase with the longest Starship static fire we've ever witnessed. But that's not all. The dramatic finale left everyone wondering, is Ship 34 still flight ready? Meanwhile, Booster 15 has already completed its testing campaign and rolled back to the